Hey guys, in this video we are going to be talking about dentition, and specifically we will be comparing dentitions of different types of mammals. But before we get into that, let's talk a bit about homodonts and heterodonts. So homodont comes from the Greek word homos, meaning same, and odos, meaning tooth. So it literally means same tooth, and this relates to animals in which all of their teeth have a similar form. On the other hand, heteros means different in Greek. So heterodont literally means different tooth, and this relates to animals that have teeth that are differentiated into incisors, canines, and molars for different purposes. And I'll talk more about these different types of teeth in a sec. But before we get into the mammalian dentitions, we just want to show you guys an example of homodont dentition, and here we have a crocodile skull. Now note that this crocodile is missing a bunch of teeth, but you can see that the teeth are a very uniform shape, and crocodiles can also replace each of their teeth up to 50 times in a lifetime, whereas mammals, which have the heterodont teeth, only grow 2 sets of teeth. One is a temporary set called deciduous or milk teeth, which is replaced by a permanent set when the skull has grown large enough to accommodate a full set. So, unlike many other vertebrate classes, mammals exploit an enormous variety of food sources. Some mammals require highly specialized diets, whereas other mammals are opportunistic feeders that thrive on diversified diets. So a mammal's adaptations for attack and defense and its specializations for finding, capturing, chewing, swallowing, and digesting food all determine its anatomy and habits. And teeth really reveal the life habit of a mammal more than any other physical characteristic. With a few exceptions, all mammals have teeth, and their modifications are correlated with what it eats. Unlike the uniform homodont dentition, mammalian teeth became differentiated to perform specialized functions like cutting, seizing, gnawing, tearing, grinding, and chewing. So mammalian dentition is differentiated into 4 types. There are incisors, which are simple crowns with sharp edges for snipping or biting. There are canines, which are long conical crowns specialized for piercing. And then there are premolars and molars, which are compressed crowns with 1 or more cusps suited for shearing, slicing, crushing, or grinding. And these different teeth are used for different feeding apparatuses for carnivores, omnivores, herbivores, and insectivores. And we're going to start here by showing some different examples of herbivorous mammal dentition. Now, herbivorous mammals, which feed on grasses and other vegetation, form 2 main groups: browsers and grazers, which are many ungulates, and gnawers, which are many rodents, as well as lagomorphs. Now we're going to start by looking at this deer skull, which is an ungulate, and notice here that the canines are absent, whereas the molars and premolars, also known as cheek teeth, are adapted for grinding abrasive plants and are broad and high-crowned. Notice that there are these lower incisors, but the upper incisors are absent. Instead, ungulates have a hard palate with a rough texture that helps them grind food. Also, look at the diastema here, which is present in ungulates and rodents, as well as lagomorphs. And the diastema is just the gap separating teeth of different functions. Here it's between the biting teeth, which are the incisors, and the grinding teeth, which are the premolars and molars. And we have another ungulate here. This is a massive cow skull, and it's really similar to the deer. It's got these bottom incisors, which it uses to bite off clumps of grass with the rough, hard palate in place of the upper incisors. And it also has the premolars and molars to shred grass into small pieces that are more easily digested. Now, if we look at a rodent, and in this case we have a beaver, and remember that rodents need to have teeth adapted for gnawing. So here you will see these chisel-sharp incisors that actually grow throughout life, and so they must be worn away in order to keep pace with the continual growth. And the enamel on the anterior surfaces of the incisors actually wears more slowly than the dentine behind, so this helps to keep the chisel-sharp edge. Now we also have a lagomorph or rabbit skull here, And like the rodent and ungulates, you'll see you've got the molars and premolars that are adapted for grinding the abrasive food. And there's the diastema between the incisors and these cheek teeth. But one major difference you'll see from the rodent dentition is that the lagomorphs have two pairs of incisors, a front pair of continuously growing functional incisors for gnawing, and a second pair of peg-like non-functional incisors. Okay, now that we've looked at some herbivores, we are going to take a look at carnivorous mammals, which feed mainly on herbivores, so they are well equipped with biting and piercing teeth for killing their prey. First, let's take a look at the jaw of this coyote here, and you'll see it's got these sharp incisors for biting, these large canines for piercing, and notice these carnassial premolars and molars, which are adapted for slicing meat and shearing flesh. And we also have a felid here. We are looking at a skull of a bobcat, which is similar to the coyote. It has sharp incisors and large canines as well as carnassial teeth, but in comparison with the canids, the felids have a very reduced dentition. That is, they have fewer teeth in general. And this reduction comes about through specialization, whereas a canid is able to slice through meat and other relatively soft tissues and also retains the ability to crack bones. Felids are really only able to slice their food. Finally, we are going to talk about the omnivorous mammal dentition, and omnivores need to have teeth adapted for eating both plants and animals. So here we have a bear skull, and you can see that it has a really versatile dentition for a varied diet. Bears don't have the short snout, long canines, and sharp carnassial teeth like carnivores, but they don't have the high crown teeth of herbivores either. So their jaws and teeth facilitate a modest efficiency at grinding vegetation, but also a modest efficiency at capturing and processing mammalian prey. Okay, now lastly, we want to show you guys one last neat mammalian skull that is pretty different from the ones we've talked about already, and that is the Cetacean Skull. So here we have a dolphin, which is a piscivore, meaning a fish eater, and you can see that it doesn't really have any specialized teeth, but rather it has numerous similar teeth in both jaws for fish capture. And the order Cetacea is actually the only large radiation of mammals to lose the precise dental position, which is associated with the evolution of both homodonty and polydonty, which means having many teeth, since dolphins have 80 to 100 teeth. And it's been proposed that these major changes in dentition are related to the absence of mastication in cetaceans, since they use their teeth to grab and hold, but not to chew their food. And one last cool fact about the cetacean dentition is that even though they lack the specialized teeth of most other mammals, their teeth are permanent and non-replaceable.